Hi everyone, here's your pre-lab help for question experiment 7b, which is synthesis of aspirin. There are two experiments, 7 and 7b, so what we are doing is a 7b. Okay, so the first one is asking for you to identify the functional group. You can also refer to the table 15.5 in the Silberberg textbook. So this functional group, what you have here, you can see that it has a carbonyl group, which is this group, and an oxygen and a hydrogen. So this group can be connected to any other carbon or any other group. This is called, when you have a hydrogen next to the oxygen, this is called carboxylic acid. Okay, and what I have drawn here is acetic acid functional group, carboxylic acid. And then the second one is asking, not this one, look here to answer question 2. Question 2 is asking what is the functional group that carbonyl group is part of, oxygen atom part of. So here you have a carbonyl group, which is this one. It's called a carbonyl group, and then that is connected to an oxygen, and then here you have another methyl group, CH3 group, and this oxygen connected to another carbon. In the previous one it was a hydrogen, but when it is connected to a carbon, we call this functional group, carbonyl group with oxygen connected to a carbon, that is ester functional group. That is what we are going to make in this synthesis during this experiment. Question number 3 is quite straightforward. It is asking, you are given the molecular formula, what is the molar mass? So basically you take 7 carbons, 6 hydrogens and 3 oxygens, and then you add up their molar masses. 7 times molar masses of carbon, 6 times the molar mass of hydrogen, 3 times the molar mass of oxygen. And when you add it up, you can find the molar mass of salicylic acid. And then suppose you weigh 2.18 grams salicylic acid. It's asking how many moles of salicylic acid. So basically, you know, if you are given the mass, how do you convert to moles? Using the molar mass, which you find in question 3. So you write question 3 answer here. That would be in grams per 1 mole. So grams to grams get cancelled. You can find out the number of moles. Okay. Question number 5. Chemical formula for aspirin is given. Mass of aspirin, molar mass of aspirin. Similar to previous question, question 3, 9 carbons, 8 hydrogens, 4 oxygens. You add up their molar masses, and then that will give you the molar mass of aspirin. Quite straightforward. Okay, and question number 6 is asking, what is the theoretical yield in grams of aspirin if 2.18 grams of salicylic acid starting material is used in the synthesis, assuming that salicylic acid is a limiting reactant? Balance equation for the reaction you will perform appears at the bottom of page 2 in the procedure handout. So in this particular experiment, your starting materials are going to be salicylic acid with an alcohol, giving you aspirin. And the molar ratios are going to be 1 to 1. 1 mole of salicylic acid give you 1 mole of aspirin. So similarly, we found the number of moles of salicylic acid in question number 4. And the same number of moles would be the aspirin that you are going to make. The question number 4 is where you found the number of moles. Question 4. Answer, same number of moles. Question 4 for aspirin. Now it is asking what's the theoretical yield. So if you know the number of moles and you also know the molar mass of aspirin, we can find out the theoretical yield. So what you need to do is you take the number of moles. Question 4 answer question 4 answer. That's going to be in moles. Okay. And question 4 answer in moles. It is the same number of moles for aspirin. And then you use the molar mass of aspirin. 1 mole of aspirin is the molar mass of aspirin which you find in question 5 answer. That is in grams per moles. So moles to moles get cancelled. You can find out the theoretical yield. Okay, question 4 answer multiplied by question 5 answer to give you question 6, which is the theoretical yield. Question 7, suppose that only 1.85 grams of aspirin product actually isolated. What is the percent yield? We know how to calculate the percent yield. Percent yield, YE, percent yield is actual yield over theoretical yield times 100 will give you the percent yield, and the actual yield is 1.85 grams, and the theoretical yield you find in question 6. Question 6 answer you put here, and then you multiply by 100. If you do your work correctly, it should give you something like 64% something. Okay, 64.9% if you do your all the calculations correct. Okay, so that's how you calculate the percent yield. And then the next one, we are given the equation how to prepare an ester from carboxylic acid and alcohol. Any carboxylic acid will react with any alcohol to give you any ester, give you the respective ester. Now, how this reaction take place? So you can see here, this is a carboxylic acid. We have seen the carboxylic acid has this functional group COOH. And this is the alcohol. Alcohol is carbon with OH. Now, during this process, a water molecule is going to lose. So the OH from the carboxylic acid, hydrogen from the alcohol, this group removes a water molecule. You see here, and then this carbon and this oxygen connects. So carbon and oxygen connects to give you the ester. And this kind of reaction can be happened between any carboxylic acid and any alcohol. Now you are given another reaction, ethyl butyrate, which you find in pineapple order. Now for question 8 and 9, you need to find out what are the respective carboxylic acid and the alcohol. What you need to do is basically you can break down the ester functional group. Now ester, the newly formed bond is this bond here. So you can break this bond right there, carbonyl and the oxygen. So similarly, this is the newly formed bond, so you break it down. So from the left side comes the carboxylic acid, and from the right side comes the alcohol. So the carbonyl group, so the question 8 answer is asking what is the carboxylic acid involved. So your carboxylic acid would be then CH3. So this part, that the blue color one, CH3, CH2, CH2, CO. Not only that, the acid functional group comes from that side, OH. And from the green, that is the question 8 answer. So you have to choose from the given choices. And then the question 9 is asking what is the respective alcohol. Alcohol comes from the green square that I have drawn, which is going to be for the alcohol, which is question 9. You have CH2, CH3, and then the O, and then to this you need to connect a hydrogen. That is going to be the alcohol, OH, CH2, CH3. Okay. What is the structure of the alcohol? So I gave you the answer for this one, that is the alcohol, O, CH2, CH3, H. So from the given choices on your blackboard, screen, you can choose the correct alcohol. And question 10, what is the role of the phosphoric acid? So normally we have to add acid like this, and then the purpose of H3PO4 is it serves as the catalyst to increase the rate of the reaction. Okay, all right then. So those are the excuse me, answers for this pre-lab. Okay, all right then, bye for now.